Alright, so today we're going to be talking about Chapter 6, Lesson 7. This is going to be solving inequalities by using multiplication or division. And again, this is going to be very similar to what we did yesterday, so we're not going to go over those inequality symbols again, or what kind of words we can use. But what we are going to do is we're going to solve these exactly the same way that we would solve one-step equations with multiplication or division. Again, the only difference is we're going to be using an inequality symbol instead of an equal sign. So, first thing that we do whenever we're solving any kind of equation or inequality is we put a line down the middle to show that the left side is kind of separated from the right side. Now, in this case, I have 5 times x. So in order to undo that, I want to divide by 5. And I want to make it look like a fraction because then this here simplifies. 5x over 5 simplifies to just x. 30 over 5, again, that's an improper fraction. So in order to solve this, I simplify, dividing by 5, and 30 divided by 5 is 6. And I simply bring down the inequality symbol. So I have x is greater than 6. Example 2 now. It says solve 3 is greater than or equal to h divided by 4. Now, this is a little bit tricky because now we have h divided by 4 and it looks like a fraction. And a lot of times when we see fractions we want to multiply by the reciprocal, but in this case I'm simply going to multiply by 4. The reason why is because then this here, I'm multiplying by a fraction, so this would be really 4h over 4, and this would be 4 times 3 over here. This side then would simplify to just h. 4 times 3 is 12. And I'm going to have it look like this. Now that is 12 is greater than or equal to h. Now, we do have an issue because sometimes we're going to be multiplying or dividing by a negative number. And when we multiply or divide by a negative number, what's really happening is we're asking for the opposite. And what makes that confusing is what we're going to have to do is actually divide. When we divide by that negative number, we're actually going to be looking at switching the inequality symbol. And we'll look at solutions to show why that needs to happen. But the process would remain the same. The only difference is once we get to the end, our inequality symbol is going to switch. So this here, in order to solve this, we would have to divide by negative 2. And what we're really looking for is the opposite. Of 2g is less than 10. Which would really be looking at 2g being greater than negative 10. Because we're going to flip everything around. So let's look at some examples dealing with this. Example 3. It says solve negative 4x is less than or equal to 4 and check your work. So I'm going to put up, we're going to solve this. And then we're going to use some different solutions that could work and show why the inequality symbol needs to switch. So, whenever I'm solving, I draw a line down the middle to separate the two sides. This is negative 4 times x, so in order to simplify that, I want to divide by negative 4. Now I have x, here's negative 1, and the inequality symbol, we're just going to kind of leave alone for right now. What I'm going to do is I'm going to pick a number that's less than negative 1, and I'm going to pick a number that's greater than negative 1, and we're going to see which one actually makes this true to show why the inequality symbol needs to be the way it is. So let's pick, let's say, negative 3. So if I say x is negative 3, that means I would have negative 4 times negative 3 is less than or equal to 4. And I want to see if this is true. Negative 4 times negative 3 is 12. And 12 is not less than or equal to 4. Which means any number that's less than negative 1 isn't going to work. So that's not good. But let's pick 3, because that's greater than negative 1. So again, I have negative 4 times 3 is less than or equal to 4. Starting to simplify, negative 4 times 3 is negative 12. And that is less than 4. Which means that my solution needs to be all x values greater than negative 1, or equal to. And that's why the symbol needs to switch. Because if the symbol doesn't switch, it does not satisfy the inequality. Let's look at a couple more here. Or one more, I guess. So, solve x is divided by negative 4 is greater than negative 5. And then we're going to graph it too. So I'm going to draw my line. This is x divided by negative 4. I want to multiply by negative 4. Because when I do this, I have negative 4x over negative 4. Keeping the inequality symbol, I'd have negative 5 times negative 4. The left side would simply simplify down to x. The right side simplifies to 20. And if I follow my guidelines that I came up with in the last example and in the previous notes, my inequality symbol should switch sides. And again, let's check this work just to make sure that this is true. So let's pick 19. So I have x over negative 4 is greater than 5. And I'm going to say that x is 19. Because right now I have numbers that are less than 20. Is what I should have for my answer. So if I say 19 divided by negative 4 is greater than 5. Sorry, negative 5. 19 divided by negative 4 is going to be negative 4.75. And this is true. Negative 4.75 is greater than negative 5. So our inequality symbol, the way it is pointing now, is correct. So let's graph it. So I'm going to make a number line. Now I'm going to put 20 right in the middle. I'll put 21 over here and 22, and going in the opposite direction I have 19 and 18. We already checked. 19 is part of the solution. 19 makes this true, which means I want my arrow pointing over in this direction here. But the question is, does this need to be filled in? Or does it left open? Well, let's find out. Let's see if 20 works. So I have 20 over negative 4. And I want to see if that's greater than negative 5. 20 divided by negative 4 is negative 5. And negative 5 is not greater than negative 5. It's exactly the same. Unfortunately, we don't have an inequality symbol that has this. If it were to have that, then this would be fine. Unfortunately, that is not there, which means negative 20 cannot be part of the solution. So our graph needs to look like this.